Assalamualaikum and salam sejahtera. For this lesson, we will discuss about partial pressure and Dalton's law. Okay, just as the gas law applies to all pure gases, regardless of chemical identity, they also apply to mixture of gases, such as air. The pressure, volume, temperature, and amount of the gas mixture are all related by the ideal gas law. Still remember what we have learned in the previous lesson? The pressure, volume, temperature, and amount of gas mixture are all related by the ideal gas law, right? So now, what is the responsible for the temperature in a gas mixture? Because the pressure of a pure gas at constant temperature and pressure is proportional to its amount, the pressure contribution from each individual gas in a mixture is also proportional to its amount in the mixture. So in other words, the total pressure exerted by mixture of gases in a container at constant volume and temperature is equal to the sum of the pressure of each individual gas in the container. This statement known as Dalton's law of partial pressure. Okay, the individual pressure of the various gases in the mixture, okay, P1, okay, we can call it P1, P2, P3, and so forth, are called by the partial pressure. And it is referred to the pressure of each individual gas would exert if it were alone in the container. Okay? But because all the gases in the mixture have the same temperature and volume, okay, temperature and volume, we can rewrite Dalton's law to indicate that the total pressure depends only on the total molar amount of gas present and not to the chemical identities of the individual gases. So we can rewrite the Dalton's law and this will come like this. So P total is equal to the number of moles of each gas, okay, for number of moles for the gas 1 plus number of moles of gas 2 plus so forth, okay, and it will be times by RT over V, okay, because all the mixture have the same temperature and volume, okay. So, the concentration of any individual component in a gas mixture is usually expressed as a mole fraction. For mole fraction, we use the symbol of X. Okay? Mole fraction is defined as the number of moles of the component divided by the total number of moles in the mixture. Okay? So, the mole fraction, we can say that the mole fraction for component 1 is the number of mole of the component 1, okay, divided by the total number of mole for the total number of moles, okay. So, but because N is equal to PV over RT, We can also write the mole fraction as P1 times by V over RT divided by P total V RT. So we will get P1 over P total. Okay, this one we can also rearrange to solve the P1. Okay, so when we rearrange it, for the partial pressure of component 1, we will get P1 is equal to the mole fractions of component 1 times by P total. This equation says that the partial pressure exerted by each component in a gas mixture is equal to the mole fraction of that component times by the total pressure. Okay, so we try to look at this example. In air, the mole fraction of nitrogen, oxygen, argon, and carbon dioxide are 0.7808, 0.2095, 0.0093, and 0.00037 respectively. Okay, so we can write it like this. Okay, so the pressure of air is equal to pressure of nitrogen plus pressure of oxygen plus pressure of argon and plus pressure of carbon dioxide. So at a total air pressure of 1 atm, we can say that the partial pressure of the individual component are, you can see here, P for nitrogen is equal to 0.7808 because it is 1 atm. Right? Okay. So, we know that P, after we calculate it, okay, times by 1 atm, okay, for the total pressure, okay, of air, the pressure of nitrogen is equal to 0.7808 atm. For oxygen, it is 0.2095 atm. For argon, is 0.0093 atm. And for carbon dioxide, is 0.00037 atm. So you can see here, after we add all of this, it is equal to 1 atm for P total. So, this example showed us that the partial, okay, so this example show that the total pressure exerted by mixture of gases in a container at constant V and T is equal to sum of the pressure of each individual gas in the container. So, this is the Dalton's law of partial pressure. Okay, that's all for this lesson. Hope you enjoy it.